Good afternoon, everyone. My name is 𝗥𝗲𝗹𝗆, Head of Training of HKIBIM. Today, our sharing topics is Decarbonized Design with BIM, Digital Engineering of NIKKEN. So today we are happy to introduce Satoshi Kame and Hiroki Tamai from NIKKEN to have a sharing session with us. Before the sharing session begins, we'll have an introduction from our chairman, Guan Ting from HKIBIM. Today, our session will be conducted in English.
So HKIBIM is established in January 2009. So we have more than 1,400 members right now. The Institute's objects include the promotions, advance of the general education and understandings of BIM management, foster general awareness, establish and advance the standards of BIM management in the industry, establish link between with the relevant institutes or tertiary educations and government departments and bureaus, statutory bodies, and other organizations. We also facilitate and help institutions in all areas of research and promote guidance on the career developments on BIM. So this is the board of HKIBIM 2025 to 2027. So the title, the cover page, there's some typo on the first page. And for these terms, since the beginning of last year, we have been established corporate members. So to date, we have now more than 13 corporate members joining HKIBIMs. So all these logos are arranged in alphabetical orders. Mainland China divisions. So we also established the China divisions and China memberships. So please encourage, and we are also looking for more China memberships. Today we have more than 35 HKIBIM China divisions and also associate membership of HKIBIMs. Young membership divisions. So this is also a new division that we set up in last terms. So we are going to continue promoting BIM to young members, students from secondary schools. So in last terms, we have CBT events up to 12 events. We have 1 forum on contractual BIMs, and we have 2 ad tasting day that we hosted together with other organizations. So we are hoping to do more and more CBT events for this term. Past events. So the most recent BIM Automation Arena 2025 was hosted this year, of great success. Social medias, the latest social media that we have set up is in WeChat. So we're still, please join our social medias on YouTube's, LinkedIn, WeChat, Instagrams. For upcomings, we will be consolidating the HKIBIM app stores into GitHubs. So please stay tuned for us to launch this GitHub. We'll be looking into more technical and automation sharings through different tools. So without any undue delay, so I'll pass it back to Kevin. Thank you everyone for your time.
Thank you, Guan. So today, our section, the title is Decarbonized Design with BIM Digital Engineering of NIKKEN. So we are happy to invite NIKKEN Sekkei. We have 2 colleagues from NIKKEN. So first of all, we have Satoshi Kame, Associate Architect registered in Japan, Global Design Group, NIKKEN, to have a presentation. And the second speaker is 𝗪𝗲𝗽𝗪, Senior Expert of Structural Designer, Digital Engineering Lab, Tech Design Group from NIKKEN. So now we will introduce Satoshi Kamei to have the presentation. Satoshi-san, please.
Okay, thank you. Can you see my screen?
Yes.
Okay. Good afternoon, everyone. I'm Satoshi Kamei, Associate Architect of NIKKEN from Japan, with my colleague 𝗪𝗲𝗽𝗪-san. I don't know where he is. He's an expert structural engineer. And we are honored to present today, and thank you to organizers and especially Andy, who invited me here from GT. So today's theme is the decarbonized design in NIKKEN Sekkei. So I will introduce about NIKKEN briefly. NIKKEN was founded in 1900, having history of more like 125 years. And NIKKEN Group consists of these three companies. And NIKKEN Sekkei is one of the largest architectural urban design and consulting firm in the world, maybe, including civil engineering, landscape design, also interior space design. And we have 10 overseas offices around China, Southeast Asia, and Dubai now, and struggling in global different markets and different cultures during more than 30 years. And you can read QR code on screen to jump our homepage to see more detailed information. And of course, we have done much major landmark projects in Japan, different use, different clients, and different sizes on every type of buildings. Then we have contributed to develop the Japan quality and experience a high-speed economic growth and social province after it. You can see all projects in our homepages. This is an TOD in Shibuya district. And we also have these kind of featured materials projects. And in global field, we hope we also can give the solutions to the social problems similar to our internal experiences. For example, these high-end secured financial buildings. And especially in China, we did a lot of TOD project, transit. This is the transit-oriented development in the dense city central. And also this is the project in Barcelona, creating and management for public spaces and so on. We are trying to realize the projects, combine the quality exported from Japan and dynamic designs in global markets. Then, so we return to today's topic, this NIKKEN Decarbonized Design with BIM and digital engineering. So today we like to focus on this topic. In NIKKEN, we have this tech design group. This group consists of these three sections. They collaborate with designers for valuable projects with their specific skills. A BIM management section supports its BIM manager to integrate valuable software and applications and design process. And they also develop BIM facilitation management platform to cooperate with building operators. And this DEL, Digital Engineering Lab, they consist of some special teams for specific engineering. And today's one more speaker, 𝗪𝗲𝗽𝗪-san, is from this DEL, so he can I introduce it more later. And last, this DDL is the Digital Design Lab. They are like pioneer to use, has to be a pioneer to use programming code to deal with, solve the architectural and urban problems, including like developing AI to make an architectural planning or 3D printing constructions and so on. So we proceed the projects fundamentally collaborating within planners, designers, and engineers, architectural engineers. And also we can collaborate with these advanced engineers to realize a more like nicer, comfortable, sustainable future. This is our today's contents. This decarbonization is one of the most trended word in these years in our architectural field globally, as you know. And today I'd like to introduce some of our projects and try to find the starting point for this decarbonized design and touching point with the technologies, including BIM and digital design. So, by the way, this is on my personal biography. So, I was born in Sapporo, Hokkaido, in Japan, and studied in Tokyo and Stockholm in Sweden, in Europe, and started working in Shanghai, China, and back to Tokyo. And now I'm living in and working in Sapporo, Hokkaido. I've been in a bit various places, and now finally came back from central city to Hokkaido. That's a greenery place. So I love the activities in greenery, like this photo. Then I'll introduce my philosophy a bit. This is my memory of the trips all around Japan when I was in uni. And it's the first inspiration of my design philosophy. I saw a lot in Japan. Then every place has totally different scenery because based on the archaeological backgrounds, the lifestyles, and climates. Those each were so amazing to me. Then I imagined I wanted to make a part of this scenery. And these scenery is a kind of a local scape generated on the local conditions. But the situation we are facing as an architect today is no longer only based on these local conditions. I think global situation must affect to the shape of the site, designing the buildings and construction. I'm not sure the word this local scape can let you imagine what I hope or what I imagine, but I now want to design a part of harmonized global scape on understanding both local conditions and global situations. I mean, yes. This is my philosophy. Then now I work in NIKKEN, can be involved in design these various global scapes. And also I personally join the regional activities to be a part of the global scapes and open my home gardens in Hokkaido to neighbors and children as the smallest global scape. So, okay, I'll show you my projects from my viewpoint, my philosophy. This project is the reason why I'm here today, because I collaborated with Andy in HKIBIM from Tech for this project. So this project is located on the Olympic Park in Hangzhou, China. You can see some rounded and curved venues in the park. And there is metro station in front of our building. So we see, we call this park TOD. And our building could be connecting the hub between the stations and the venues in the park by shaping our building with flow like this curve. This flow-like curve is not only for people visiting, but also the landscape, greenery, and the wind passing through, and the sunlight making shadows. Actually, this landscape on the rooftop is not completed yet. It can be like this in the near future. This is the photos under construction. This crowding is so complicated. And now it's like this, but in the near future, this place is to be the concentrated wellness park for living and visiting people here. So in order to realize this complex design, we collaborated with internal and external specialists, both locally and globally, including Gary Technologies. And of course, this construction is much difficult, but our clients and the construction teams had made much effort to realize this complicated shapes and crowding. When it's completed, this roof garden and the Olympic Park connected each other in one shape and one flow to generate the new parkscape activated in 365 days and 24 hours. So the building's almost completed like this. So the technology allows us to trace natural elements to shape an architecture form. We need to, but then we need to decide the form carefully from the composition between every element which is in the site and surrounding the site. We might transform the surrounding visible and invisible environment and scape by our forms. So this is my this statistic. So I will go to the next project. The second project is 𝗥𝗲𝗽𝗆, a cross fusion of digital and real. Actually, this is not my project. It's designers are they. But I like to introduce this project because I agree the concept of this and it must be replicated another place maybe in Japan. And this project won the AIJ Architectural Institute of Japan Prize to 2025, the last year, this year. On the architecture design division, the prize of it. That means the annual best project in Japan. So because the idea and this method of using technologies is quite noted in the current social situation in Japan, I think. So this project is located near to Osaka, Takatsuki City. This area, the area of this city covered a part of Japanese Alps mountains. like as the similar situation with other Japanese cities. The concept is create a forest in the city central by using internal woods in the city. The forest fills 66% of the land in Japan. These patterns, the wooden patterns in timber louvers, are familiar in historical Japanese cityscape. And traditional structure of Japanese houses is wooden framework construction method. So human life needed much internal woods materials. Many trees were planted in the forest near to the city more than 50 years ago in Japan, every place in Japan. But actually, globalization and modernization changed the production of internal woods and supply. So when the designers started this project, they recognized the quantity limitation of internal woods in Osaka Prefecture. So Osaka Prefecture, produce 1,600 square meters of woods annually. They, of course, not only one team to use these woods, so they need to plan how much woods are required for this theater to order woods to the Forestry Association at the beginning of this project. These are NIKKEN, our featured works using wood materials and each wood's quantities. They have recognized through conversation with association if they order these quantities at once only for Osaka internal woods, it make a bad effect to the ecosystem of Osaka forests. Then they decide to use 350 square meters of woods divided 3 years only for divided 3 years only for finish materials, not for structure. This must be the best quantity and quality for Osaka forest, they thought. And they how to use without waste for these limited woods was the next problem. So the logs sawed up and distributed according to the sectional parts. Different parts has different properties. The core, number one, the central part, the core part is usually used for the structural timber, with slit to the core not used for finish. And the middle part has a waterproof feature. And the outside has water absorption, and it can be impregnated to be non-flammable. So according to the material, these properties, the woods were distributed to the different places, creating a different and specific expression. And this wood distribution and design has been controlled by BIM and other familiar design tools. This is the method to control the quantity of wood materials. The number of sawed timbers classified and calculated was estimated before they cut in the forest. Of course, this number might be changed when they sawed and calculated after. And designers make patterns for each division using like Grasshopper or other parametric design tools. And at the same time, BIM can calculate how much timbers are used for to compare to the supplied quantity. They must not like make lacking and also waste. This is the exterior waterproof louvers made from the middle part timbers. It is designed with Grasshopper, and tags were put on each louvers with sizes in it, leading the error-free installing along the tags. It's the louvers from inside. The sunlight is passing through, so feel like in the forest. This is the interior wall made from the outside part of wood, which this is non-flammable liquid impregnated. These interior materials are necessary to be non-flammable in our architectural standards in Japan. This is the small hall. In this hall, the wall and ceiling are made from the outside part timbers. Their angles of each timbers are controlled from sound effect simulations like this. And at last, the grand theater are totally covered by the wood core cubes. As you see, like you can see the cubes on the walls and the ceilings. Of course, the sound effect and visuals and construction ways are also simulated in BIM and other programs. But actually, the designers and craftsmen finally complete this work in like handmade way like this. So this is the masterpiece collaborated technologies with craftsmanship, I think. So this is the visuals, final visuals of the whole. So from this project, I think the technology might help to update the relationship between the human life and the forest. It's forgotten away after the global modernization at once. And this topic might be a Japan local one, but it is also, I think it's global scape regarding to the global environment. So then I will pass the microphone to Tamae-san once.
Thank you, Satoshi-san. Do you hear me good?
Yes, we can hear you.
Okay, thank you. Okay, so I'm Hiroki from Digital Engineering Lab of NIKKEN Sekkei. DEL is made up of several small expert groups. They include Facade Engineering, NIKKEN Wood Lab, BCP and Safety Design Lab, and Computation Building Environmental Engineering team. I lead this small team called 𝗪𝗪𝗪𝗪. We offer a diverse range of design experiences and cutting-edge computational technologies. Our spot expand from brainstorming to evaluation of the project as we collaborate with architects to develop new ideas. So today I'd like to introduce the methodologies that a 𝗪𝗪𝗪𝗪 team uses to reduce embodied carbon in structures. So form finding, structural form optimization, and graphic statics are our primary approaches. We do other things as well, but I will talk only about these three today. Form finding, corresponding to how nature uses materials, and structural form optimization is related to finding corresponding to how nature make a building ecosystem in nature. Then graphic static shows us graphically how form and forces are related by duality. Okay, let's start from form finding. Let's look at these four simple but yet essential structures. Shells under compression on the left, spider web under tension, soap film in tension, and self-stressed spine and muscles under both tension and compression. All of these shapes transfer forces with zero or almost no bending. This is how nature maximizes the use of material strength. Did you notice that these materials have no shape of their own? To build a structure with these materials, we need to give the right shape through which the force can transfer smoothly without generating bending in the members. They are namely shells, cable, and membrane structures and tensibility. They can be stiffened by pre-stressing. Unfortunately, you cannot choose a form like freeform for this efficient system. You have to find a form in equilibrium. This is why this technique is called form finding. These are built examples designed using form finding techniques. They are stone masonry by Gaudi, concrete shell by Isler, cable net loop by Fly Otto, spoke wheel roof and cooling tower by Schleich, and grid shell by Schober, and tensibility by Kenichi. How did they find the forms? Historically, before computer became available, they used physical models or graphic approaches, as shown in this slide. Nowadays, we use computational method. I will show you a few visualization of computation form finding for typical structures that requires form finding process. These are, for example, grid shell, cable tower, or these are variation of spoke wheel system and footbridges. Please note that these demonstrations are conceptual and intended to illustrate how they work and how they have been applied. And my concept study has nothing to do with actual design of the structure used as reference in the pictures. Although I love to show you how we can apply these techniques in our office, that's a bit unfortunate that I'm unable to share most of the project because they are ongoing project. But I will show the next slide illustrates how the form finding process fit into a collaboration between architects and structural engineers. Using this project that was assumed to be built with cables and membranes. Starting with architecture concept shape, the model is shared with architecture modeling and form finding input geometry. With this geometry, form finding is performed like this. Then equilibrium form is compared to original architect concept. The structural analysis is executed based on this equilibrium form. Otherwise, conventional structural analysis hardly find a solution because of the stability issues in calculation. All right. To give you some more ideas about what you can do with form finding techniques, the following slides show more conceptual studies. This study shows that if the footbridge deck is an S shape, the arch follows accordingly. I hope this result starts inspiring you. If you have suspension cable instead of arch, and the deck is not a single S, but two S's, then it is another pretty shape. This can go a bit further in detail to show that equilibrium form can be further balanced in detail. This has an eccentric load, but please recall that all elements are in equilibrium. The following two slides will illustrate the form finding of cable net structure used to suspend retractable membrane roof. The first one assumes a stadium scale. The boundary is a rigid ovary ring. This form finding problem has more than one unique solution, equilibrium solution. So we can choose one solution such that the membrane can fold along longitudinal directions without tearing. The sum of the force differentials is minimized to reduce the required clamp size. The next one is similar to the first one, the last one. Different is that the boundary for this project is not prescribed. Instead, it is a part of variables to be determined. In this project, the covering was proposed for amphitheater in one of the school campus in US. These two cases demonstrate that a form determined by a form finding technique can represent not only a form equilibrium, but also an architectural concept. This is an experiment, total experiment. In my opinion, one of the limitations of tensile structure used in architectural design is that tensile system always require a saddle shape. Can a tensile structure have a convex shape all around? I challenge this question, and this is one of my answers. All right. So the next story will be about structured form optimization. Let's ask ourselves what the optimal design means. We can find hints in nature again. Do you know this fish? This is a flounder. It lives at the bottom of the sea, lying down flat like this, so it must feel higher water pressure than other regular fish, especially when he pulls up his body from the ground. He needs a lot of force. Let's see his bones. It is different from other fish in terms of the position of the joint. Probably this makes it easier for him to pull up the flat body up from the ground. So what else? Let's look more closely. If you look very carefully, you can find each bone shaped like a wide flange steel beam. I think it's amazing. And yes, I sketched this because I forgot to take a photo when I was cutting and cleaning this fish that I remember very well. So next time when you cook this fish, please watch very carefully. One more. This is the picture of giant cactus. They can grow in extremely hot and dry regions. They store water in their stem. So where is the structure then? If we take a look inside, for me, it looks exactly like a tube structure for super high-rise building. So what can we learn from these two creatures that lived in extreme environment? So my interpretation is that adaptability extends diversity. This is actually how I look at form optimization of the structure. Technically speaking, optimization is nothing more than minimizing something under specific conditions. It can be displacement, steel tonnage, etc. Anything can be chosen. The other variation in structural optimization, such as optimal assignment of cross-section, topological optimization, form or shape optimization, or mixed use of these techniques. Why do we like to optimize the shape? Because it is more effective than cross-section and more practical, in my opinion, than topology. So let's see a NIKKEN project now. This building, part of a project in Jinan, has an irregular floor slab layout. The column layout in a regular grid would not make sense. We applied a heuristic optimization algorithm to find the better column positions, which in the end appear very random, but successfully reduce the floor displacement to 1/3. This is a regular one. This is the optimal column position. This was a competition in China for railway station complex. The number 6 was the key concept for architectural and structural design, symbolizing the prosperity of the city, as well as 6 petal flowers, and snowflakes. We used hexagon module to integrate roof and column systems. By applying horizontal load in form optimization, we can see that bundled columns are transformed into a bracing arrangement. In the following slide, I will show you a grid shell form optimization for a partially rectangle but asymmetric plan. It is required to have a squared grid mesh in plan, and of course, the quadratic frame are supposed to have a planar for glass paneling. If you take z coordinates of all nodes as a design variable independently, you will end up having twisted panel. So we apply a translational surface, as shown in the right. By translating polygonal generatrix along directrix, we can generate a surface with all facets being planar. Therefore, our design variables are shape of generatrix and directrix. However, we have another challenge in this problem. Boundaries have to be modified accordingly. So these are our proposal for the designer. So please recall that all quadratics are planar and boundaries are updated during the calculations. So sometimes we don't need to make plane panels strictly planar. In the following slide, I will demonstrate how to create a smooth grid shell without using control points of the nerve surface, like in rhinoceros. The simple case study illustrates that the corrugated roof can reduce the displacement, potentially leading to reduction of the steel tonnage. However, with all the coordinates being independent design variable, the solution shape will be zigzag and not so smooth. So we apply Gaussian function as a low-pass filter, analogy to these pictures, sound or graphics. So depending on the size of the filter, we can change the degree of the smoothness of our structure. So this project is an example in which filter operation we filter the optimization process. The filtering process is performed not just at the end, but it is done throughout the whole optimization process. In this case, without filter, it can potentially save 40% of steel tonnage and the corresponding carbon dioxide emissions, but it goes a bit too far from the architect's desired shape. So we filter with the proper size, then we can achieve a smooth approximation of the desired form while saving 15%. But else for form optimization, again, is an experiment to see how form follows the force and how the filter can effectively smooth the surface. Now that was without filter, but that was zigzag. Now with filter, then can you find the form follow somehow moment diagram, right? So now finally, we will explore the duality of form and force. It is more than how form relates to force and form, vice versa. What word this duality indicate is that form is identical to force. Or like when you see a form, you already see force. So when you studied architecture in school, many of you learned how to solve the truss graphically. Remember or not, all you need is a pen and a ruler. Translating this geometry into force diagram. The force diagram, the lengths represent the magnitude of the force. There's actually another step that you might not have learned in school. You can actually play with the force diagrams to make the length smaller or zero. In this case, the force between 3 and 2 becomes 0, and these becomes equal. And you trace back to the form to have this truss, which do not need diagonals. So I will show you 3 legendary built examples that are believed to utilize this classic technique. The first one is the storage roof in Chiasa designed by Robert Mayer. Now you already know why this truss does not have diagonals. The second example is Eiffel Tower. I also didn't know that this was also built using graphic static. Again, this does not have diagonals. As a result, the force magnitude becomes symmetric and therefore efficient, structurally efficient. The third one is the 𝗪𝗲𝗶𝗆 Bridge by Mayer again. He used graphic static to determine the arch shape of the bridge and the sequential variation of the cross section. By the way, if you look for the picture of this bridge, all pictures have the same angle like this one. This is why I saw. You see me here. So what's your step when you go there and take a picture by yourself of the bridge? So unfortunately, again, I cannot share any project that we use a graphic static approach to design some of the in some of the project, but instead I will briefly explain the duality of the method and how it can be applied to the form finding of a spoke wheel structure. So this slide illustrates how form and force are dual. So let's go. This is your familiar truss form diagram with force indication right here. Elevated vertically to make a polyhedron. Okay, this one. So each node of the polyhedron is accelerated by 3 XYZ coordinates, right? With these three information, you can represent one surface actually. This is a dual relation. Then convert this polyhedron to this another polyhedron, which is green here. Now project down to the ground. Then you have the force diagram that you saw in a few slides back. So it's like magic, right? But this is dual. Okay, so applying this concept, you can perform form finding for spoke wheel loop system much more efficiently. The left diagrams are forms, 2D forms of spoke wheel system, while this one is a force diagram. They are identical, but the forms are different. And this force diagram represent equal and uniform forces in ring members. And actually, in spokes also all equal. But you can choose forms. So this is an optimal set, but you can choose the form. This is the important point. For example, this one is selecting the form by minimizing the sum of the length, square length of the ring. And the other one is minimizing the variation of the length. Good things are not only the force optimal set, but also you can draw this geometry without using nonlinear calculation at all. Then applying the duality, the polyhedron, you can solve the spoke wheel with more arbitrarily selected this ring geometry, like these ones. So this is totally new horizon in this field. So this was just a brief introduction of this AD stress polyhedron because I couldn't show any of our project. So, all right, this is my final summary. Form and force matter for structural efficiency and the economy of natural resources and reducing embodied carbon. Form and force matter for architectural design expression and diversity of structural potentials. Okay, I return the microphone to Satoshi-san again.
Thank you, Tamae-san. So I will share my screen again. How is the time? Almost 1 hour past. Okay, now the microphone was returned to me, and the time already 1 hour past. Almost 30 minutes left, so it's enough. This is the last one for today. So the all landmark reborn for the future. This is the project in Beijing, Zhongguancun high-tech landmark 𝗪𝗲𝗃, you know, the most famous place, IT place, you know, how to say. Okay, I will explain later about it. This is renovation and conversion project. The original building is was like this. This building called 𝗃𝗏, located in Zhongguancun, Beijing. It's known as China's Silicon Valley, which is the core of innovation. This 𝗃𝗏 building was built in 20 years ago. It was the most famous electrics market in Beijing. We can we could see the latest IT and digital devices at that time, and were sold in it, and a lot of young people came to buy it. It was one of the iconic landmark of the initial age of digitalization. These are before and after of conversion images. Why was this 20-year-old building should be refurbished? It's like bit young or bit quite new building was refurbished. Generally, and most of conversion projects consider about the preservation. But in this project, actually no one need to preserve this anonymous building from the historical and cultural reasons. This is a quite new type of conversion, I think. I can tell you these 3 reasons. One is speed, and second is program, and the third is system. The speed. About speed, recent Chinese growth has been extremely rapid, as you know. This 20 years are enough longer to change like construction technologies than the same term in like developed countries. And the second one about program. In this project, we were required to convert an electronics market into an innovation offices as per local demands. And the third one is the most critical reason in China. So in China, a developer must obtain government approval to use the land. If the development changes, Chinese regulations requires projects reapproval. So major real estate in China belongs to the national government. As such, it is possible that the developers are increasingly opting for refurbishing instead of new construction. But the most important thing is the most critical reason regarding to China's land use system. It's not critical in conclusion to evaluate the efficiency of this kind of development and sustainability of global environment. Let's see the details of this project. So this old electrics market was hollowed out and reborn with these 3 distinct visions. Vision 1 is the value of conversion. An atrium was created from this deep central commercial floor. This hollowed out floor area was added to the building's high value portion as office space without changing net floor area. This table shows the floor area boundaries and increase and decrease. It had to be done within the strict framework inside the former development. This is the sectional view of the entire development with 3 hollowed out voids in pink and extended floor in blue dot. We rearranged the floor area to maximize value, adapting to shifting social demands. Vision 2 is eco-friendly renovation. To begin, this existing curtain wall installed 20 years ago was refurbished and updated to the latest Chinese building standards. The environmental performance was boosted by at least 30%. Interior MAP systems and landscape were also renovated. I introduced them later. The Vision 3 is innovation networking. The underground corridor in our project connected to the metro station and the city center. This corridor penetrates the building's common areas, achieving an urban innovation network. The network leads to the office lobby. Workers, innovators, and investors can meet and collaborate over coffee here. The landscape was also redesigned to match the neighborhood. This is the main office entrance open to the station plaza. As such, urban public spaces and circulation were recreated. And this network will add value to the Zhongguancun innovation ecosystem, with this Dinho building serving as the core. These 3 visions were realized by updating the existing building and its stock. Through this process, we have undertaken efforts for 2 different kinds of decarbonization. A is the embodied decarbonization, and B is operational decarbonization. For the first, building use may continue while value is increased in response to stronger demand by transforming like this. This image shows the demolition process for the atrium space. This is not simply a hollowing out task. Much care was required to mine the structure. An added floor area with steel structure was integrated with the existing concrete structure. In result, compared to scrap and build, embodied carbon emissions were cut by almost 60%. Then, this transformation also includes improving the building's environmental performance, as I mentioned. The top light brings the daylight into the atrium like this. And this is the entrance hall. The brightly lit entrance hall is now suitable for high-grade offices. And the high-efficiency MEP equipment was installed to meet changing demands. And it also contributes to conserve energy. You can see the elevators. These elevators are a new one for the office floors, for instance. And this eco-friendly curtain wall also saves energy, improving heat insulation quality by 40%, while these vertical fins helps to block solar radiation. And greenery also helps to insulate against solar heat and emits fresh air for workers. And workers can refresh and be more like creative within these green spaces. For example, this rooftop. And through such decarbonizing transformations, an annual operational carbon emissions were cut by like almost 40%. And finally, this significant environmental conservation was achieved like this, and the investment efficiency was also achieved as construction costs were cut by 60%, almost the same with carbon, the same as carbon. And $94 million saved from Tower A alone. And by 50%, rents have also increased. At the same time, 35,000 tons of CO2 reduced. And 10,000 flights from London to Singapore, or 70% of all of Singapore forest's annual absorption capacity. These efforts resulted in obtaining LEED Gold and WELL certifications. And in process, this dinner has also become a place for people to enjoy a better social life, as the core of innovation. And our clients continue to try sustainable efforts. This digital twin for facility management could evaluate the amount of energy flow in building and cities to reveal the sustainability of it. This is a business model with a bright future. It's the most important, I'd like to say, is that this original building doesn't have a cultural and historical value to be preserved in general way. It's just an anonymous and general buildings. We can find everywhere in China, Japan, Hong Kong, everywhere in the world. But so we believe this development model must be replicated around the world as the catalyst for like global sustainability. And the problem is how to increase replication of such renewal projects. I think one of the answer is if BIM and other technologies predictably estimate the efficiency and sustainability, we might be able to encourage more developers and the investors to challenge to these kind of a new development. Thank you for your kind attention. If you have any questions or requests for collaboration, please message me to an email or something. I'm not sure how I share my email, but thank you for today.
Thank you,
That's it.
Satoshi-san. Thank you very much. And thank you, Hiroki-san, as well. So this is the presentation, and we are now going to the Q&A sections. So members and ladies and gentlemen, if you have any questions, please using the Q&A functions on the toolbar or using the chat box to enter your questions. We can have a discussion here. So at the meantime, we are waiting for the question. Let me just start the first question. Satoshi-san, I saw your presentation. One of the theater is so cool. It looks so cool because all of them they are made with the wood. right?
Yes.
So does those would comply with the regulations? I think they does the government have a concern of those fire rated regulations or something like that?
Yes. Yeah, we have a lot of regulations in Japanese architectural standards.
Yeah.
Then that is the changing to increase to use the wood materials,
Mm-hmm.
but it's still yet difficult because how do you say they want to let us
Mm-hmm.
use a lot of woods, but the most important thing is the how do you say the safe city. So
Yeah.
and
Right.
the hurdle is high,
Yeah.
but it's changing.
Mm-hmm.
So we have a lot of as I showed you, we have a lot of featured wood using wood projects.
Yeah.
So we're trying to realize much more wooden projects.
Yeah. So another slide I saw that about the column optimizations. So from the typical arrangement of those columns to support the structure, I think this question is going to Haruki-san. I saw the presentation that you have optimized the column arrangement for the support of those slabs, right? So they look so random. So how can you correctly transfer those message to the construction or the contractor, they can build it correctly? Maybe it's not only can explain it in 2D, maybe, I guess.
Well, this one, right? I think
Yeah,
so.
exactly.
Or expressed in the drawing, but I think it's more importantly I don't know how much we can talk about it, but we develop a system that column can fit anywhere, not like particular places that has a regular beam.
Yeah.
So then, of course, during the project is developing and the construction developing, there are some things that I suppose not to talk much, but we develop a system to accommodate this irregular layout of the column.
Okay.
Then I think we just show the position in the drawing.
Okay. That's cool.
Hello, Satoshi-san and Hiroki-san.
Yes.
So yeah, Andy is with us today. So yeah, he just joined. So I think one question from Andy. I think you worked with him together at the Hangzhou Xingda project before on the facade optimizations. So he's trying to get a some thoughts from both of you, right? In the design process, right? Finding inspirations for structural or architectural forms is often very challenging in terms of balancing both key disciplines. Do you have any suggestion for everyone regarding the relationship between the design with the people and nature? Any advice on seeking ideas for such design solutions? Because initially when you presented a lot of these architectural forms, and then Hiroki-san's will help to supplement with thoughts using how do we tackle and provide structural solutions to these forms. So I guess there will be a challenges between balancing between two of the key disciplines, right? In terms of architectural and structural, and both of you are talking about forms, right? In designing. Right.
So when I started this Hangzhou projects, I saw the perspective drawings of the future park, And of course, we find a lot of these venues in a shape like curved and circles, not like static shapes. Then in this park, if I started to design our project, if we make like static shape, we can't create the harmonized scenery in a park. So we started to make the kind of flow-like shape in the beginning. And at the same time, I started the research for the materials for exterior, like aluminum panels and a lot of other materials to install into the curved shape, and check the costs and the difficulty to construction. Then finally we decided to create this kind of shape, flow-like shapes, and attract the people to going through from the station to the Olympic venues, and to also create the value to the shopping malls and the office buildings. This is, I don't know I can understand well, as you said, the balance. But that is my answer.
Yeah. Sorry, Hiroki-san.
Yeah. I may add some more words from my point of view. I don't know how well, in many projects or in most cases, I think the architect leads the total concept, including the form, architectural form. And then maybe some structural engineer also have a strong idea to push his idea of the form of the structure. But I think many structural engineers propose the form from the aspect of structural safety, integrity, and cost. Cost for everyone, right? Not the structural engineer is not the only one who care about the cost. Architect, project manager, everyone care the cost, right? So when the structural engineer said, not so good, let's not do that. That means actually he had some evidence or some something that he cannot reject actually. Like scale is the thing. When the scale is in a relatively small scale, if you use steel, for example, it's a strong material. You can do anything if you have money. But when the scale becomes larger and larger, there is some point that you just have to follow. Everyone has to follow, not only structural engineer, but architects also need to follow. That's a problem, the scale. So beyond some certain scale or order of the scale, everyone somehow have to compromise with their own ego, and except for the budget. Budget is another problem. Then also maybe these days, everyone has to care about the natural resources and carbon emissions. So we shouldn't do much something that you have another alternatives. You have to think twice, right? So if there is a difference, maybe the difference is here. One is scale. The other one is structural engineer is reject your idea, probably most likely not from their ego, but based on material strength, integrity of structure, safety. So I think if we understand like this, then we can find an solution that everyone is happy.
Yeah, I think definitely this is a great answer to all our audience. I think it's about the compromise. It's about coordinations, right? And it is about team effort. So I guess both of you have really nailed down the questions. Another questions is when we talk about BIM, right, and it involves part of the parametric designs, right? BIM is part of parametric designs. You know, as from the as NIKKEN Sekkei, right? You are involved in architecture, design, engineering, and so on. So how much of these parametric designs could you actually weight it, you know, during your design stages? Could you just give your honest opinion? How much could you weight if you are giving the time to do it, right? Or in actual project executions, the clients will always say that there's time and budgets to everything, right? So if you got a choice, how much time and if you can put a number to it, how much percentage will you be giving to your teams to focus on parametric design?
What answer? Satoshi-san, can you answer?
It's a bit difficult because as I told you, we have the special team for the kind of BIM and digital design. But basically, we designer use the kind of parametric design or BIM programs in a design process. So it depends on the domestic internal project in Japan is not so much people are using parametric design, but in the global field, we also require the dynamic, beautiful design. So much people are using the kind of programs, and sometimes in a lot of cases, ask Tamai-san or other special teams to help our design. So the number of people, I'm not sure, but it's so much people can use the kind of, especially young designers can use the kind of parametric design tools.
Oh, okay. I was a bit confused or not clear about parametric. When you said parametric design, maybe you were thinking about optimization with Pareto optimization to find which is better.
Definitely, yes. Yeah, that's
Okay.
right.
Because I was thinking other things also to propose alternative solutions, not necessarily parametric from one idea, but architect structure engineer also propose 3 or 4 ideas, right? Usually, we are not giving a client just one idea. If you think this is the best, you still have to give two or 3 more for the client to convince your idea is the best or give them an option. So that's one thing. And sometimes the solution really, the process starts from that position. If you start from the bad idea, parametric design give you the best answer because it is already some like handy, you know, you already have starting from the minus position. So I think the conceptual alternatives from many aspects, I think it's first important things. And parametric is secondary if I maybe it's a little bit too strong statement to say parametric is only the secondary, and I believe it's not true. But as in my story, for example, changing the cross section for fixed layout of beam and column will help a little bit, but not much. But if your big picture layout concept of the column and beams were in a better position, you already have a big advantage compared to the bad layout. So sometimes it's difficult to go over these alternatives only by parametric design, because parametric design you already have set of variables. But in a big picture, alternative ideas has different parameters, different design variables. So finding this is not necessarily parametric study, in my opinion. Then parametric is adjusting, fitting the better in your already narrowed scheme, but maybe your starting point may not be the best.
Yeah. I think it's a good point, because sometimes the optimized design maybe is not the most suitable design, right? Maybe not the best constructible design, maybe not the best looking design, but they are optimized, right?
Yeah. So it's a adaptation of the conditions, design condition.
Yeah, thank you. So maybe let me just wrap up. Let me ask the last question. I like to ask this question to the architect, because sometimes when we are talking about the BIM to the architect, especially architect, some of them they may find BIM is a very good tool for them to do a better design, but some of the architect they think BIM is a kind of the burden to limit their design. So I cannot do anything I want, because it is a kind of the cage my ideas. So so what do you guys think? This statement is a burden or is a help?
I think we share some ideas, I think, already. Kami-san, you go first.
I did. Actually, I don't use BIM in design phase because it's a kind of limiter, as you said. It's too much complicated, so we have to decide a lot of things in the beginning stage. But so I think it's better to use BIM for the specific goal in each phases. For example, in the beginning of the project, we can use BIM to make the maximize volumes or calculate the project management costs or something. And in a later phase, like construction, before the construction, we can use BIM for the crushing report and other integration of curtain wall and structures and MAP and something so complicated things. So we can, I think we my opinion is just my opinion is the using valuable programs including BIM to the specific phases and goals, and we can control management to management is the necessary for it. So yeah, that's my opinion.
I have I think similar feeling that BIM, like a start BIM, when you think very starting point, I mean make something from zero, but you still you think the BIM at the same time. It's like you try to draw a construction drawing from the beginning, or like you ride the jumbo jet to buy a cigarette to the next corner, right? So it's too big to drive. It's like a big trailer to ride to buy just a bottle of water. So I think it's important to choose the phase. But once when the time comes, when the phase comes, or the type of the project, if it is a regular project, that's something you can just repeat from the past work. Then you can start using BIM in the earlier phase than more special one. I think it's common feeling about how to use BIM and get the benefit from being using. Then I don't not against at all. No, I'm totally fine, and I totally agree that we should use more and more. But still, the phase of the technology of the BIM is still some. It asks you to do more work than in the phase that you don't want to think about it.
Yeah, you're right. You're right.
I think it's about the thing. One day maybe AI or another technology or another way of using it or another structure of people organization, expert and do something different. Maybe you can do sketch, but somebody or a machine is already working to make a BIM at the same time.
Yeah.
Until the time like this comes, BIM is still hectic, I think, in the beginning.
Yeah, thank you, Haruki-san. Very good point. So I think we are overrun a little bit today, but so I think there's no any more question from the Q&A section. So I think this is going to be the end of the sharing sessions. So thanks again from Satoshi Kame-san and Haruki-Tame-san from NIKKEN to have a great sharing session to us. Thank you very much, both of you. So we are going, this is the end of the sharing sessions. So have a good day, ladies and gentlemen. Thank you very much. Thank you.
Thank you.
Goodbye.
Thank you.
Thank you for today. Bye.
Thank you.
Bye-bye.
Bye-bye. 山口さんお疲れ様です。
お疲れ様です。